So welcome to the discussion on probability. In the last class we have seen what do you mean by continuous probability, and we had discussion about what do you mean by a probability density function and a distribution function, and the most important property we saw is for a density function minus infinity to infinity f of x dx is 1 and minus infinity to a f of x dx is nothing but probability that x is less than or equal to a, and this is same as capital F of a, where this is your distribution function. This small f is your density function, and we saw one important property that density function will start at 0, end at 0. This one will start at 0, end at 1. Correct? Yes or no? These are the things we saw, and also we saw that integral a to b f of x dx is nothing but probability that x lies between a and b, that is this, and this is nothing but f of b minus f of a. This is what we saw in the last class. Okay. Now, one important concept I will like to introduce between the that is the difference between the discrete and continuous probability. Okay, now I will introduce you this concept through an example. Okay, now let S be the sample space of a throw of a dice. It is very easy to realize. It is very easy to see this in case of with this example. Okay, now what is the probability that we get a number less than 3 on a throw of die? What is this? I want to get the probability of a number. What is the probability that on a throw of a dice I get less than 3? So I can get 1 or I can get 2. Total number of possibilities are 6. So there will be 2 out of 6. So this is 1 by 3. Now what is probability that I get a number less than or equal to 3? What will be the probability? I can get 1, I can get 2, I can get 3. So less than 3 means 3 is not considered, whereas less than or equal to 3 means 3 is considered. So here I will get 3 by 6. Totally 3 events are favoring out of the total 6 outcomes. So I will get the probability to be 1 by 2. So 1 by 3, that means what? Probability that I get less than 3 is not equal to probability that I get less than or equal to 3. Correct? If I want to generalize, I can say that probability that x less than equal to a is not same as probability that x is less than or equal to a in case of discrete events. Okay? Okay. Now, let us say the same thing in continuous case. I have a sample space. Okay, I have all the numbers listed from 1 to 6 in continuous sense. Means what? I will have 1.1, 1.001, 1.00001. Everything will be listed between 1 and 6. Correct? Now here, what is? Let me say that f of x is the associated distribution function, density function. Now, what will be probability of x less than 3? What will be the probability that x is less than or equal to 3? Before writing in mathematical terms, let us analyze what I mean by this statement. When I say probability that x is less than 3, that means x can take any value from 1 up to 3. It cannot take 3. It can take any value like 1, 1.0011, 1 like that till 2, 2.5, 2.7, 2.9, 2.999, 2.9999999 like that. That means x can take a value up to 2.9999. This number of 9s keeps on going. Even if I write 9 throughout my life also, the number of my life will end, whereas the number of 9s won't end. So many 9s are possible. So probability that x is less than 3, I include all points up to this. Correct? Now, so how many points are there? Infinite points are there. Okay? Now, let me say what is probability that x is less than or equal to 3 means what? What is this meaning? Here, x can take up to 3. X can take up to 3. That is, this number whatever I wrote 2.9999999, so long I am writing, after the difference between here and here is just this one point called 3. The difference between these two cases is only one point called x equal to 3. Correct? So, among infinite points, one point cannot make a difference. Correct? Yes or no? So, in continuous case, probability that x is less than 3 is same as probability as x less than or equal to 3. This is a very, very important point. That means if I generalize, how can I write this? Probability that x is less than a is same as probability that x is less than or equal to a. Both are same. So this is a very important concept. Please remember, in continuous sense, probability x less than a is same as probability x less than or equal to a, whereas in a discrete case, they are not same, they are different. We proved it by one example also, correct? So in discrete case, probability x less than equal to a is not same as probability that x is less than a, because here I include the point up one below a, and I know what is the point below before a. Correct? Here when I say 3, I am including the number up to the number before 3. So I know what is the number before 3 to include that point. Whereas here we don't know what is the number before 3. So in between x less than 3 and less than or equal to 3, there is only 1 point difference among the infinite points, and among infinite points 1 point cannot make a difference. So in continuous sense this is same, whereas in discrete sense they are different. Please remember, this is very, very important. Now we are going to see about some interesting concept called expectancy and variance. This we would have done in our school days itself. Let us understand what we did in our school days. Okay, we would have done these problems in our school days. We would have taken x, then we say x is some 5, 6, 7, 8, 9, like this. We would have done this in statistics. Then we will find what is x bar. That is nothing but average value. This average value will be 7. If you calculate, you will get the value as 7. Then we will use to compute what is the deviation. Deviation is nothing but x minus x bar. So here we will get minus 2, minus 1, 0, 1 and 2. Now if I try to find the average deviation, it becomes 0. Why? Because minus 2 minus 1 plus minus 2 plus 2 will get cancelled, minus 1 plus 1 will get cancelled. So I get 0. That means there is a deviation above the mean and deviation below the mean will get cancelled each other. That is, this is the mean value of x, but we have the values below mean also, above mean also. These two are cancelling each other. That is, though there is a deviation, the average deviation is 0, because the positive deviation and the negative deviation are cancelling each other. So this is giving us a misleading concept. This is misleading us because actually there is a deviation, but the average deviation is 0. So we think that there is no deviation. Correct. So to get rid of this, what we do is we do d square. When I do d square, what will I get? I will get 4, 1, 0, 1, 4. I am squaring each values of d. Now if I take the d square, the sum is 10. So d square bar is 2 now, because 10 divided by 5 entries are the totally 2. So this is called the mean square deviation. This mean square deviation is nothing but variance. This mean square deviation is also called variance, and root of variance is called standard deviation. Standard deviation. This we would have done in our 10th standard. I am sure everyone of us would have done in our 10th standard. Now this we did on our 10th standard for discrete values. Now we are going to do here for continuous values. So now what do we understand? Mean is nothing but x bar. Variance is nothing but mean square deviation. And what is deviation? Deviation is nothing but x minus x bar. That's how we computed deviation, right? For every entries of x, we found what is the mean and we subtracted the mean from the every entries of x to find the deviation. And square of the deviation we found, and the mean of square deviation is your variance. And standard deviation is what? Standard deviation is what? It is root variance, or this is nothing but root mean square deviation. This is nothing but your RMS in short. Root mean square is RMS deviation. This is what we are going to do in this session now. And mean, I am going to call it as expectancy. Mean is nothing but expectancy. So expectancy of a random variable x, I am not going to prove this, is defined as integral minus infinity to infinity x into f of x dx. This is how I define the expectancy of x. Okay, where f of x is the associated density function. Okay, now E of x is called the expectancy of x, and E of x is defined as integral minus infinity to infinity x into f of x dx for a continuous case. For a discrete case, f of x is E of x is defined as summation xi into probability of xi. Okay, summation over the range. We know what is the range. So in discrete case it is defined like this, xi into probability of xi, and in continuous case it is defined as minus infinity to infinity x into f of x dx. Okay, now we are going to explore into this more and more. So this is what we saw just now. This is in the case of continuous. This is the case of discrete. Clear? Don't worry about the proof. We are not going to prove this. We will take this as a formula and proceed ahead. Okay, E of x is given as this. Now, having said E of x is going to be given like this, what will be E of x? E of x will be I like to denote E of x as mu here, which is the average value. Mu and E of x both are same. I am using the notation called mu for denoting E of x. Okay. Now, I want to find what is variance of x. What is variance of x? What is variance of x? By definition, mean of square of deviation. Square deviation. Correct? That means if I find the deviation and square it and take the mean of it, I will get variance. Okay? Now, look at how I am going to play with this definition to find the value of variance. Now, E of x is like, now I will introduce you this. E of x is like a mathematical machine. Mathematical machine. What this machine is going to do, whatever I am going to feed here, whatever I am going to give here, it is going to give the average value of E of x will generate average value of x. And what is x? X is what is given to the machine called E. See, my E is like a micro, like if you feel it hard to understand, take it this way. Your E is a mathematical machine. That's what I am trying to say. Say let E be like something like a microwave oven. Your microwave oven, whatever you keep it inside, it is going to heat and give you. If you keep coffee, it will heat the coffee and give you. If you keep food, it will heat the food and give you. If you keep cake, it will going to heat the cake and give you. Correct? So, whatever you keep, the microwave oven is going to heat you and give it to you back. Heat the substance. I'm sorry, it's not going to heat you, I'm sorry. Sorry for the misuse of the word. It is going to, whatever substance you are going to place it there, inside the microwave oven, it is going to heat it and give it to you back. Similarly, E of x is going to take the, E is a machine which is going to take average value of whatever you are going to put here. If you put something here, it is going to give you the average, that is, in short, if I have to write, E of this will give you average value of this. So if I feed this dot, E of x is going to give the average value of dot. The dot can be anything. Correct? Now, having said this, let us revisit the definition of variance. What is variance of x? It is nothing but mean of square deviation. Correct? This is what is the variance. Now, I have to take mean of some function. Mean is nothing but average value. Correct? So, if I feed the square of deviation to the mathematical machine called E, it will generate me the variance of x. Correct? That is nothing but, variance of x is nothing but E of square of deviation. That is what? X minus average value of x, because deviation is what? In the case we found, right, deviation for every value is computed as x minus x bar, correct? So x minus mu is the deviation square. Correct? So if I feed x minus mu square to the machine called E, it will give me the mean of square deviation, which is nothing but your variance of x. Correct? Now by definition, what is x minus mu square? E of x minus mu square. E of x is what? E of x is what? Integral x f of x dx minus infinity to infinity. And what is f? F is a probability density function. So integral minus infinity to infinity f of x dx is 1. Now see how I am going to use these things to generate v of x. So E of x minus mu the whole square is nothing but integral minus infinity to infinity x minus mu the whole square into f of x dx. Correct? E of x is x into f of x. E of x minus mu square is x minus mu square into f of x dx. That's it. So whatever value you feed here, in short, if I have to write here in this notation, this is nothing but minus infinity to infinity something into f of x dx. This is how you will get. Correct? E of x is nothing but x f of x dx minus infinity to infinity. So E of something is nothing but Mathematically it lacks meaning. I understand this has no meaning in the mathematical terminology, but for a representation, for a symbolic representation, I am writing this. This has no mathematical meaning, by the way, because dot is not a mathematical thing. Okay, so we come back here, x minus mu the whole square into f of x dx. Now what we will get from here? Minus infinity to infinity, x minus mu the whole square I am expanding. So I will get as x square minus 2 mu x plus mu square into f of x dx. Okay. Now I can split the, I'm going to multiply and split the integral. So this is nothing but integral minus infinity to infinity x square f of x dx minus 2 mu x f of x dx plus mu square f of x dx. Correct? That's how it will look if I multiply. This can be written as, I am going to split it now, minus infinity to infinity x square f of x dx minus 2 mu into, mu is a constant, okay, mu is constant, average becomes constant, x is a variable, whereas the moment you compute the average value of x, it becomes a constant. So minus 2 mu, I will take it outside integration, x f of x dx between minus infinity to infinity plus mu square f of x there, right? So mu square is a constant, integral minus infinity to infinity f of x dx. Now you see, the moment you write it, some mystery is going to happen. Now going by this dot analogy, something into f of x dx minus infinity to infinity will give you average value of this quantity, correct? That means what will this give you? X square f of x dx minus infinity to infinity will give you what? Average value of x square, correct? Minus 2 mu, mu and e of x are same, so I am just using both together, mu and e of x are same, 2 mu minus infinity to infinity x f of x dx, this is nothing but e of x. Mu and e of x are same, please remember that, plus mu square into what? F of x dx minus infinity to infinity, this value will be 1, correct? So plus mu square you will get. So 2 mu e of x is same as 2 e of x into e of x plus e of x the whole square. So this part is what is this? So this will become e of x square minus 2 e of x square, e of x the whole square plus e of x the whole square. So 1 e of x square and this gets cancelled. So variance of x is nothing but, let me write it in the next page. So variance of x is nothing but e of x square minus e of x the whole square. This is what is called variance of x. We derived the formula for this. This is very important. This is very important. Okay. So we know how to calculate e of x and v of x. Okay. Now we are going to solve. Rather you can take this as a problem or a formula, whatever you want, but these are very important for gate. We are going to arrive some 3 to 4 important results. Okay. Let y be a random variable such that y equal to ax plus b. X is another random variable. I will write in short form as RV, whose mean is e of x and f of x is the density function of x. Find E of y and v of y. This is very important. Okay, this is one part. Okay, let us take this as part A. Part B, find variance of a constant and expectancy of a constant. Of a constant. This is very important. Okay, so these are two. Oh, anyway, part B is nowhere related to this statement, but still we will solve it together. Okay, now y equal to ax plus b. So you want to find E of y. E of y is what? E of ax plus b. Now going by our analogy, E of something is nothing but this thing into what is E of ax plus b? It is nothing but minus infinity to infinity ax plus b into f of x dx. So if I split it up, what will I get? Integral minus infinity to infinity ax f of x plus b f of x the whole into dx. This is nothing but minus infinity to infinity ax f of x dx plus minus infinity to infinity b f of x dx. So this is nothing but a is a constant, I can take it outside, a into minus infinity to infinity x f of x dx plus b into minus infinity to infinity f of x dx. So this is nothing but a times, what is this? It is e of x plus b into minus infinity to infinity f of x dx will be 1 because f of x is a probability density function. So e of y is nothing but a e of x plus b. This is very important. If y is ax plus b, then e of y is nothing but a e of x plus b. Clear? Fine. Now we found that e of y is nothing but a e of x plus b. Now second thing is to find v of y. What is v of y? V of y is nothing but what? V of e of y minus y bar the whole square. Correct? Mean square deviation. Correct? E of x is nothing but v of x is nothing but e of x minus x bar the whole square. So v of y will be e of y minus y bar the whole square. Correct? So this is nothing but, you see how it is going to play now. E of y square minus 2y bar plus y bar the whole square. Correct? Yes or no? Yes or no? This is what it is going to give you. Correct? Yes or no? Now, I have just expanded the whole square relation here. So now what you will know, what you can do, this is nothing but expectancy of y square. What is y? Y is nothing but ax plus b, right? Ax plus b the whole square minus 2 into ax plus b. I am substituting the meaning. And what is y bar? Y bar is nothing but a into e of x plus b. That is y bar plus a e of x plus b the whole square. Now if you simplify this big expression, what will you get? Here you will get a square x square plus 2axb plus b square minus 2ax 2a square e of x minus 2ax b minus 2ab e of x minus 2b square. Correct? Then plus this part I have to expand now. That will give me a square e of x square. Correct? Plus 2a e of x into b plus b square. Now you see what is going to happen. Many terms are going to get cancelled. B square, this plus b square can get cancelled with minus 2b square. Correct? Then you have plus 2axb. Let me take a different color. Plus 2axb will get cancelled with minus 2axb. Then minus a square e of x square plus 2ab e of x minus 2ab e of x. These two will get cancelled. Correct? So now what you are getting now? E of a square x square minus 2a square e of x. Correct? Plus a square e of x square. This is what you are getting. Correct? A square x square minus 2a square e of x plus a this one. So this is nothing but e of a square x square minus what you will get here. This should be minus 1 second. I think we made some mistake here. A square x square minus 2a. Hey, this should be minus 2a square x e of x, right? 1 second. Let me revisit this term. I think we missed up something here. So this should be what? A square x square plus 2axb plus b square minus 2a square x e of x, right? There should be one x here. See, minus 2ax into a e of x. So it should be minus 2a square x e of x minus 2axb minus 2b into a e of x minus 2b square. So here we got this. Then this should be a square e of x square. Okay. Now this is a square x is there here. A square. Now it is correct. A square x. Now this is correct. Clear? So what you are getting here? A square x square minus 2a x. See now how I am going to 2a square x, right? So I can write that as 2ax into a e of x plus, see it is 2a square x e of x, right? So 2a into x into e of x. I am splitting and writing. Then a square e of x square. Correct? Now what you will get this as? Wantedly I split. Now you can write it is C. It is in a square minus 2ab plus b square form, right? So this is nothing but expectancy of what? Ax. Expectancy of what? Ax minus a e of x. Correct? The whole square. Correct? So a is common here. I can take a common outside. It is nothing but a e of a square into x minus e of x the whole square. Correct? Now e of a is a constant, so it is not going to affect your. See, remember e of ax plus b. See this thing here. Y is nothing but ax plus b, right? E of ax plus b is nothing but a e of x plus b. Correct? Yes or no? So it's as good as saying that this A can be brought outside, correct? So using the same analogy here, I can write this as A square into E of what? E of x minus E of x is what? E of x is what? Mu the whole square. And what is x minus mu the whole square? E of x minus mu the whole square? It is nothing but variance of x. So variance of y is nothing but a square variance of x. That is, variance of ax plus b is nothing but a square times variance of x. It's a very important result. If you are not remembering the proof also, please remember the result. It is very important. Clear? But I will see, the proof is not very difficult. It is just 3 steps to answer. 3 to 4 steps. If you if you forget this also, if you remember the steps, you can derive this in the exam very fastly. That is what is needed. Okay. Then, so what did we prove? We solve now. E of ax plus b is nothing but ae of x plus b. Variance of ax plus b is nothing but a square times variance of x. These are 2 very important results. Okay. Now, second part, what we solved part A here. What was part B of the problem? What is expectancy of a constant and variance of a constant, correct? Variance of a constant means what? A constant cannot vary. So theoretically, means by common sense it should be 0, correct? Because variance is going to say how much it is varying, correct? Now first let us find expectancy of a constant and let us validate our common sense, what our common sense says here. So let the constant be k here. Let me say that. So I have to find E of k. E of k will be what? Minus infinity to infinity k into f of x dx. Now k is a constant, so k will be brought outside, minus infinity to infinity f of x dx. So f of x dx, integral minus infinity f is nothing but 1. So constant. So average value of a constant is constant itself. Correct, right? See, 10, if I add 5 times, if I try to find the average value of a constant, it will be that constant itself, right? Say, how will you find the average value? Say, for example, if you have 5 instances, you will add all the values of that 5 instances and divide by the 5. So if you have, say, a constant, you will add k plus k plus k plus k plus k 5 times. You will divide by 5. So 5k by 5 will be k only. Correct. So if you add n number of times and divide by n for averaging it, constant will take the same value. So average value of a constant is constant itself. Clear? Now what is variance of constant? What is V of k? By definition, what is V of k? It is nothing but expectancy of k minus k bar the whole square. Correct? Because variance of x is defined, that's how only, right? Variance of x is nothing but x minus x bar the whole square. Correct? So variance of what is k bar? E of k is k bar. Expectancy of k is the average value of k, called k bar or k mu, whatever you want to call. So variance of k is nothing but expectancy of k minus k bar the whole square. But k bar is nothing but k. So variance of k is nothing but expectancy of 0. Because k is nothing but k bar, so k minus k will give you 0, 0 square will be 0. And what is expectancy of 0? 0 is a constant, expectancy of 0 will be 0 only. So variance of a constant is 0. The constant does not vary, so the variance is 0. This is again a very important result. These are very important results. Expectancy of a constant is constant itself, variance of a constant is 0. So now what is expectancy of Ax? Expectancy of Ax is what? expectancy of Ax will be what? Integral minus infinity to infinity Ax f of x dx. This is nothing but what? A into minus infinity to infinity x f of x dx. This is nothing but A into E of x. Clear? Now, E of Ax is nothing but AE of x. Okay. What will be variance of Ax? Just now we saw that, right? This is nothing but A square V of x. So, variance of x, this will be this, whereas E of Ax is AE of x. That is, in short, if I have to write, expectancy of 2x is nothing but expectancy of x plus x. This is nothing but 2 expectancy of x. Correct? Whereas variance of 2x is nothing, the 2 expectancy of x, this is nothing but E of x plus E of x. All these are same. E of 2x is nothing but E of x plus x. By using the above relation, if I use this relation, what will I get? E of 2x is nothing but 2E of x. And if I expand 2E of x, it is nothing but E of x plus x. That means E of x plus x is nothing but E of x plus E of x. Whereas variance of 2x will be 2 square variance of x. That is nothing but 4 variance of x. This is not variance of x plus variance of x. Not equal. Please remember. So expectancy of x plus x is nothing but expectancy of x plus expectancy of x. Whereas variance of x plus x, that is variance of 2x, is not variance of x plus variance of x. This is again a very important conclusion. So variance takes a non-linear relationship, whereas expectancy takes a linear relationship. Clear? Fine. So with this we end to this class. In next class we will be seeing more problems related to expectancy and variance. Clear?